Hey, what's happening, guys? Getting ready to start a new project today, March 20th, 2022 for this year. And it's going to be a PCB project in conjunction with PCB. It's going to be a modular system for learning basic electronics. And we'll put it together. And, well, let me just show you what I'm talking about. Sorry about the audio there. I don't know what happened. The computer ate it. So I had to re-record it, and I'm re-recording it on a little handheld device, so it's probably going to sound different throughout this part. Anyway, this is the first circuit. It's just a simple voltage regulator. Power's going to come in through a jack, goes through the switch. It's going to light up the LED just to tell us it's on. Then we've got a 7805 with its input capacitor, output capacitor, and a small reservoir capacitor as well. And the power goes out a plug at the end. So here's what the layout of the board looks like. We just have the power coming in from over here on the left side. Goes through that current limiting resistor for the power LED, through the regulator and its associated capacitors, and boom, out the other side of the board. And these boards are all designed to be the same size, and they're all hopefully going to plug together. At least that's my hope in this whole thing. But we have to start with the most basic one, of course, which is the power supply. You can see there where the jack comes in and where the power goes out over here. Of course, that's going to be bent over 90 degrees so that they just kind of slide together. I think that'll work out pretty well. But, yeah, there's a 7805, and it's going to have a heat sink on it as well. So this will be coming in at 9 volts, and it's going to have to drop, what, 1.25 plus about 3.5, 4, almost 4 volts. So we definitely want to have something there in case of that. So, like I said, this project is in conjunction with PCB. They have been great to work with over the years. And what I want to draw your attention to right now is their assembly service. They're having a special on their assembly service for $30. What that means, you design the board, give them the drawings. Yeah, they can get the parts for you, or you can send them parts however you want to do it, but they will put the boards together. Dude, that's 5 boards for 30 bucks. Do you imagine the amount of labor involved in that? So yeah, that is just a phenomenal deal from PCB. So we got the boards back from PCB. Yeah, I did them in red. I know I normally do my stuff in black, but for this, I think I'm going to call it Project Rose. For Project Rose, they're going to be red boards. The colors, school colors here are red and white, so I figured that worked out pretty cool. But there's our board, and we're going to start putting it together. So we want to start with the smallest stuff first, and that would be the resistor. And unbelievably, I don't have a 2K resistor. So since this is coming off the unregulated of a 9-volt supply, we're going to go with a 3K, you know, just to give us a little bumper room, so to speak. So you're probably asking yourself, well, why is he doing it off the unregulated side? That's stupid. Well, you'll see in a minute. It's not for any deep electronic reason. It's more of a gimmicky thing. Like I said, I'll show you in just a second. Alright, I think next up, put in the power switch. This is a super simple board. And that is one of the reasons I made it like this. Was because I know that the kids at the high school and the middle school probably aren't going to have a lot of access solder clamps and blue tack and everything else like that. So I want to make sure that we can get these soldered up easily enough, because we're going to give these to the school in two ways. We're going to give them completed kits for the younger kids, the middle school kids, and then we're going to give them uncompleted kits that the high schoolers are going to be able to build. That'll be something that they can say they left behind. All right, the jack's not really smaller, but might as well just put it in next. It's no problem. This is probably the only component on this board that the kids might have trouble soldering, because those holes are pretty big. So you got to get pretty hot, melt a good amount of solder, but I think it should be okay. Yeah, it'll be good. Now we'll solder these up. It's going to be funny, not having my kid there anymore. He turns 18 in just a few days. And in just like a month and a half, he's going to graduate from high school. I'm pre-experiencing the empty nest syndrome. All right, so we need a 0.1 microfarad cap. Sure, I got some. And I do. There's a 0.1. We also need a 0.33. Huh. Do I have 0.33? Oh. There we go. Then I need 1,000, but I don't have 1,000 small enough to fit that, so we'll go with 100. It's just a reservoir cap, so it'll be fine. All right. I don't know if these are going to fit. I definitely used the wrong footprints here. Man. Man, oh man, oh man. Hopefully it'll fit. So I can definitely see a Rev 2 of this board coming, just to correct a couple of my my faux pas, so to speak. Come on, fingers. Well, actually, it's not the fingers. The fingers are doing what the eyes tell. Tell them to the eyes, just can't see them little holes. All right, let's get those two soldered in. The next one might be a bit more entertaining. Sorry for the hoarse voice and mucusy noises I'm sure I'm making. Not much I can do about it. All I can say is, at least it's not COVID. Just the cold, and that's the second one I've had this year. And if you don't get them twice. Ooh. A little bit of a solder bridge there. But she gone now. All right. Sorry I bumped the camera. I'm always bumping it. Let's see. You gonna fit in there? Am I gonna get that lucky? Oh, look at that. Look at that. Yeah, I'm still gonna have to spin another board. But at least that'll work for now. Yes. Having trouble getting in there. Yeah, I guess this will be a little bit difficult to solder without like some helping hands or something along those lines, but I got it. But I got a lot of experience. I don't want the high school kids fighting that, so we'll have to figure something to do about that. Alright, so now we need a regulator. Regulate. Oh, you gotta be kidding me. Look. Oh, I'll be back in a minute. Alright, pardon me while I move the camera here. I buy these kits off of Amazon. They're like 20 bucks. And basically, they're just a bunch of parts. That's a MOSFET. That's a 78 something. 78 something. Alright, I'm gonna have to look in here. I'll be back in a minute. It didn't take me too long. Go through what, 2, 4, 6, 8. Found it on the 9th try. Anyway, I just wanted to tell you guys. Doesn't have to be this brand. But you just see these electronic component kits for about 20 bucks. You get a bunch of stuff in them. And it is all useful. Alright, so we're going to put a heat sink on him. Give me a second to do that up. Alright, let's put it together here. Thermal pad on the heat sink. Insulator through the package. Screw through the insulator through the package. And into the heat sink with the heat mat. I'll tighten her up once it's soldered in place. I'm just going to do the old trick where we solder one of them here first. Then we sit the thing where we want it. Let the solder cool. Oh, I should have looked at that from 2 angles, huh, Paul? Then we'll solder it in the rest of the way. So, I want to ask you guys for your help with this. And no, I'm not talking about money. I need your brains. give me ideas for little circuits that I can put on little boards like this that the kids will be able to plug together and take apart and all that good stuff. There we go. Now we're tight. So then we need our female header. And if I don't have the right one here, I might just go with a male header for this. Let's see if I can cut these. We'll bend it. .90 degrees like that. You just gotta solder it in place. Give me a second. And that leaves one thing. The power LED. So we'll get that guy in there. Get it soldered, and that should about do it. Oh yeah, it's that flat. So I better check that first. Like that joint. That should do it. Alright, so hook it up to some power and make sure it works. Alright, so I got 9 volts, 1 amp set on the power supply. Plug her in. Turn on the power supply. She's not pulling nothing. Huh. What's going on there? First of all, I got to make sure we got power coming out here. Just making sure nothing feels hot. Pardon the splotch of light there. That light out there. That doesn't help at all, does it? Dagnabbit. Alright, well, let's see. Oh, this is going to be fun. Looks like I'm not getting any power out. Let me take these test clips off of here. Do it the old-fashioned way. No, I'm not getting any power out. I wonder what's going on. Hang on. Well, now we've shifted over to the power supply, which, as you can see, is still got this output on. So let's see what we get now. Oh, backwards, but yeah, I'm getting 9 volts here. But nothing here. Yeah. Would you look at that? One moment, please. All right, I think we got it. Let's see. We got our 9 volts now? Yes, we do. All right. Now we plug this guy in. See what's what. Did you guys see the LED flash? I don't know if I saw it flash or not. If it did, it just burned out. Let's see if written voltage here on the output. Really? Well, I guess that's a fail. I'm going to have to go in and redo my design. Well, it happens. This video's gotten long enough, so I'm not going to troubleshoot it to you guys watching. But thanks for watching, and thanks PCB for sponsoring this video, and for just being a great friend of the channel and electronics hobbyers in general. Alright guys, if you enjoyed this, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. Big thanks to you. That's it. I'm out. Peace.